So welcome to Dr. Ravi Education and Career YouTube channel. Hit subscribe and hit on bell icon to get regular updates. So in this we'll discuss the system of equations under matrices as a part of linear algebra. So we'll begin with a definition, that is a linear equation. So what is a linear equation? An equation of the form a1x1 plus a2x2 plus so on an xn equal to b, where a1, a2, an and b are all constants and a1, a2, so on an are called as coefficients. So then this equation is called as a linear equation in terms of the variables x1, x2, so on xn. Now the system of equations. The system of equations is nothing but a combination of linear equations. If we observe here, the first one is a linear equation, the second one is another linear equation, and so on. So we had a combination of many linear equations, that is system of equations. Now the point here is solving the system of equations. Solving the system of equations means what? So what does it mean? That is, we need to find the values of the variables x1, x2, so on xn, which satisfies all the equations, that is all the linear equations what we had. So that is nothing but the solving the system of equations. We need to find the values of x1, x2, so on xn, which satisfies all the equations. How to do it? So in this process, first what we do is we express the system of equations in the matrix form. So how to express them in the matrix form? So that is in the form of Ax equal to b. So where A contains all the coefficients a11, a12, so on a1n. Similarly, the second row a21, a22, so on a2n, etc. And the X matrix is a column matrix or a column vector which contains all the variables x1, x2, so on xn here. Equal to the right hand side contains a matrix B, which is a column matrix or a column vector contains b1, b2, so on bn. Now you can verify, if you multiply A into X and equate it to B, you will get that all the corresponding system of equations. That is, so we need to express the system of equations in the matrix form as Ax equal to b. Now before solving the system of equations, we will see the solution of the system of equations, and we will have some discussion related to the solution of system of equations. When we discuss system of equations, we talk about two terms. One is consistency, other one is inconsistency. Consistency means, so it says that the system is going to have solution, that is solution exists for the system of equations, then we say the system is consistent. If the solution is not there for the system, that is solution doesn't exist for the system of equations, then we say the system is inconsistent. Now how to say whether the system is consistent or inconsistent? Now to make a point here, I mentioned, say even though we go through the procedure to solve the system of equations, most of the times our interest is to find whether the system is having solution or not, that is whether the system is consistent or not, consistent or inconsistent. If so, we want to find the nature of the solution, how the solution is going to be, instead of seeing the solution, right? So then how to have it, right? Now we'll see the types of solutions, right? So suppose if we take one example, x plus 2y equal to 3, 2x plus y equal to 3. So as discussed, what we are aware is we need values of x and y which satisfies both the equations. Now for example, from trial and error it is observed that x equal to 1 as well as y equal to 1 satisfies both the equations. So that means x equal to 1, y equal to 1 is the solution of the system of equations. And apart from these values, apart from x equal to 1, y equal to 1, there is no other value of x and y which satisfies both the equations given. That means what we say is the system of equations will have only one solution, that is what we call as unique solution. Right? Now, if we see graphically, if we represent, then what it indicates, or from graphical representation how we observe is, now if we take the first equation which is a straight line, second equation which is also a straight line, then we observe there exists only one point at which both the lines intersect. That point is 1, 1. That means, so there is only one point at which both the lines intersect. So that point is nothing but the solution. So then from this we can say the system is having unique solution. Now another example, if we take x plus 2y equal to 3, 2x plus 4y equal to 6. Now just we had a trial and error. So when x equal to 0, y equal to 3 by 2, then both the equations are satisfied. When y equal to 0 and x equal to 3, then both equations are satisfied. Similarly, when x equal to 1 and y equal to 1, that means when we substitute these values, both these equations are satisfied. So like this we can have many values for x and y, or many combinations of x and y which satisfies both the equations. So that means how many solutions the system will have. So we can say infinite number of solutions. Right? So now if we take the graphical representation, if we represent these two, then both are the lines which coincides. Right? Now as discussed, we need the point which satisfies both. If you see here, all the points on the line, if you consider any point on the line, it satisfies both the equations. Then the question comes, how many points are there? Many points, right? Therefore, we say infinite number of points are there on the line which satisfies both the straight lines or both the equations. Therefore, we say the system is having infinite number of solutions. So, other case, that is x plus 2y equal to 3, 2x plus 4y equal to 8. Right? So, if we try to solve this, we won't find any value of x which satisfies both the equations. Right? Therefore, what we say is there is no solution for this system. That means the system is said to be inconsistent. If we plot these two, now we will get two lines which are parallel. That means they are not going to intersect anywhere further. That means there is no point which lies on both the straight lines. That means there is no solution. So now that means we had three types of discussion. One is the system will have solution. If system will have the solution, it may be unique solution or it may be infinite number of solutions. The other one is the system may not be having no solution, that is inconsistent. Now, so we will take the system of non-homogeneous, that is same whatever we discussed is non-homogeneous. So that is the system of equations in matrix form, that is Ax equal to B, is said to be non-homogeneous system. Right? So where as seen, as discussed, we have two cases. One is consistent, other one is inconsistent. Inconsistent means no solution, right? Consistent means solution exists. So that solution may be a unique solution or it may be infinite number of solutions. Right? Now the question comes, how to know whether the system is consistent or not? If so, whether the system is going to have unique solution or infinite number of solution. So for which we take the help of rank of a matrix. That is, if rank of AB equal to rank of A, if rank of AB equal to rank of A, then the system is said to be consistent, right? That is the first condition. Rank of AB equal to rank of A, then the system is said to be consistent. If not equal, that is rank of AB is not equal to rank of A, then the system is said to be inconsistent. Inconsistent means no solution, right? Once the system is consistent, then comes whether it will have unique solution or infinite number of solution. So when it will have unique solution is if rank of AB equal to rank of A, that equal to n, that is n is number of variables in the system of equations, then the system will have unique solution, that is rank of AB equal to rank of A equal to n, then it will have unique solution. If rank of AB equal to rank of A less than n, then it will have infinite number of solutions. Okay. Now we'll go through it, but mostly it may not be required for us to know how to solve it. Mostly what we require is to find the nature of the system of equations, that is how the solution is going to be. That is mostly what we require, but it is always preferred to have an understanding on how to solve the system of equations and find the solution. So for that we will take one problem and see how to solve it. So now we will consider one example: x plus y plus z equal to 3, 2x plus 3y plus 4z equal to 1, 3x plus 2y plus 5z equal to 2. Now as discussed, we can write this in the matrix form as Ax equal to b, where A is a coefficient matrix, right, where 1, 1, 1, so 2, 3, 4, 3, 2, 5, and the x is the matrix containing variables, where variables in the problem are x, y, z. So x, y, z comes here, equal to the b's here 3, 1, 2. Right. So next is, so we need the rank, right? So rank of AB as well as rank of AB, right? Then what we do is we'll take the matrix AB, which is called as augmented matrix, right? So AB means, now if you go back and see, A is this matrix and B is this matrix, right? So combining together we'll get augmented matrix, that is AB. Now what we require is the rank of the matrix. We know to find the rank of the matrix, we need to convert the matrix into echelon form with the help of row operations only. So here, so what we do here is by using the operation. So first what we do is we'll try to make this element as 0 and also this element as 0 with corresponding operations. The operations we use here are R2 is R2 minus 2R1 and R3 is R3 minus 3R1. So then when we perform these operations, when the first row remains the same and second row is changed to 0, 1, 2, minus 5, 0, minus 1, 2, minus 7. So next we will try to make the second element as 0. So with a suitable operation. Now here we go for operation, that is R3 is R3 plus R2. Right? So then we get the matrix as 1, 1, 1, 3, there is no change. Second row is also, so no change in the second row. Third row 0, 0, 4, minus 12. Now if you see here, we had the matrix in echelon form, and here if you see, so this until this part it is A, and if you take the complete matrix it is AB. That is, we had the matrix AB as well as matrix A in echelon form. Now so we see this matrix, right, we had this echelon form of the matrix. Now what is rank of AB? Rank of AB is the number of non-zero rows. So here this is a non-zero row and this is a non-zero row and this is also a non-zero row. Therefore rank of AB is 3. And rank of A we want. So now only if we consider this part, this is matrix A, right? If you take this matrix A, which is also in echelon form, where number of non-zeros rows are 3, 1, 2, 3, right? 1, 2, 3. Therefore rank of AB is also 3. That means rank of AB equal to rank of A, both are equal. That therefore we say the system is consistent. That means the system is having a solution. So now the discussion comes whether it is going to have unique solution or infinite number of solution. So next, the number of variables comes into picture. The number of variables in the given problem are 3, that is x, y, z. Therefore, rank of AB equal to rank of A equal to number of variables. Therefore, the system is having unique solution. Right. So this is mostly what we look for. Suppose if we want to find the solution, it's very simple here. Now this matrix what we had in echelon form, we rewrite this matrix in the form of equations as, so x plus y plus z equal to 3, y plus 2z equal to minus 5, 4z equal to minus 12, because this this A we need to multiply it by x, that is x matrix. So then we get these equations. Now from this we get z value, substituting z value here we will get y value, substituting y z values in the first equation we will get x value. So now we get x equal to 5, y equal to 1, z equal to minus 3, that is which is unique solution. Okay. Now second case, suppose, so I am not going to take a new problem, and suppose consider the previous matrix which is an echelon form, right? And in that, suppose after doing some operations we are having this matrix, right? This is the matrix which is in echelon form. Now we will see which type of solution it is going to have. Now in this case, rank of AB, if we consider the complete matrix, if we consider that is AB matrix, then which is in echelon form, then rank of AB is number of non-zero rows. Here 1, 2, 2 non-zero rows. Therefore, rank of AB equal to 2. And if we consider only this part, A part, this part, so again this is also in echelon form, right? And here the number of non-zero rows are 1 and 2. Therefore, rank of A is also 2. So rank of AB equal to rank of A equal to 2. Therefore, we say the system is consistent. That means solution exists. Then next comes which type of solution it is going to have, right? And here number of variables are 3, right? X, y, z. So therefore, rank of AB equal to rank of A is equal to 2, which is less than number of variables. Therefore, the system is going to have infinite number of solutions or infinitely many solutions. Now how to get, mostly this we may not require, but still to have an understanding. Now we rewrite this matrix into equations form. X plus y plus z equal to 3. Second one is 0x plus y plus 2z equal to minus 5. Now if you see here, we had two equations in 3 variables. So then to solve it, we have to assume any one of the variables as some k. Suppose here in this case what we have taken is y equal to k. If we take y equal to k, from this we will get z value, then from y and z we can get x values. Now if you see the solution contains k, that means by giving values to k, equal to 0, 1, minus 1, etc., we can have infinite number of solutions, that is infinitely many solutions. So this is the second case. Now the third case, suppose after doing all the transformations, this is the matrix finally we are getting, which is in echelon form, suppose. Then what will be the solution? Now in this case, if you see this complete AB matrix, if you see, rank of this matrix is number of non-zero rows, that is 1, 2, 3. So 3. Then A is this part only, right? So where the rank of the matrix is here, it is having 2 non-zero rows only, right? This one as well as this one. Therefore, rank of A equal to 2. So that is rank of AB is not equal to rank of A. Therefore, there is no solution. That is, the system is inconsistent. Now we can check also, right? If we rewrite this into the equation form, x plus x plus y plus z equal to 3, x plus y plus z equal to 3, y plus 2z equal to minus 5. Last one, if you take 0x plus 0y plus 0z equal to minus 12, that is 0 equal to minus 12, which is an absurd thing, right? 0 equal to minus 12. That means the system is not having any solution. Okay. So like this, we'll have, when we talk about a non-homogeneous system of equations, we talk about three types of solutions. One is the unique solution, other one is infinitely many solutions or infinite number of solutions. Third one is there is no solution for the given system. Next is homogeneous system. Right? Homogeneous system means here when the b becomes 0, ax equal to 0, that means it is like x plus 2y plus 3z equal to 0. That means the all right hand sides are zeros. That is ax equal to 0. That is homogeneous system. In homogeneous system, always there exists a solution, because if we take x equal to 0, y equal to 0, z equal to 0, always these satisfy the system of equations, that is, which is called as trivial solution or zero solution, right? So here we need not check for this, because always this is a solution which the homogeneous system will have. Only thing what we have to verify is it going to have any other solution, that is a non-trivial solution. Non-trivial solution is nothing but non-zero solution, which is infinitely many solutions. So now what is the condition here? So if rank of A equal to n, then the system will have only trivial solution. That means it won't have non-trivial solution. If rank of A less than n, then system will have non-trivial solution also, that is non-zero solution also. So based on rank of A, that is rank of A equal to 1, only zero solution. If rank of A less than n, then system will have non-zero solution also. So like this, we discuss the solution of system of equations with respect to homogeneous system, with respect to non-homogeneous system. Okay. Thank you. Subscribe to channel and hit on bell icon for regular updates.